Assalamualaikum warahmatullahi wabarakatuh and a very good day. Today we continue with clause 8. So hang on. Well, let's continue. This is where we left off last time, see? The assured disruptive discharge voltage test for DC, since we are in clause number 7, right? DC. So as you can see for 7.4.3 and 6.4.3, right, they are similar. Okay, they are similar in terms of here you see the voltage applied and raised as described in 7.4.1. Okay, the only difference is their voltage, right? And then here there's a yellow note. If the recorded voltage is below the assured discharge voltage for a certain number of times, then it is a pass. All right, because this test is assured disruptive voltage, meaning if during the test it the insulation breaks down before the voltage, the assured disruptive discharge voltage, then it is a pass. If you raise the voltage above the disruptive discharge voltage that has been set for the unit under test, it didn't discharge, then it is a failure. Okay, make sure you're clear about that. So we move to the next page, if I may. Right. And then in the next topic, for sure, either 6.4 or either 6.5, 7.4.5 or 8.5 is about the measurement system. Remember, this is the next part, okay, of this subject. Now, for clause 8, the first page is about impulse waveforms, and that it is divided into either lightning or switching. All right. Then take note of the two different characteristics of the timing of the two waveforms. This is just about the wave shapes. If you try to compare both lightning surge waveforms and switching surge waveforms, you will see there are two complete waveforms. One is very steep, very high, while the other one is much, much slower. The first one is lightning. Even in this figure, it doesn't look very steep, but look at the timing. Around like microseconds. So it occurs in a very short time. Okay. On the next slide is switching. And switching, well, it looks the same, but it is still an impulse, but the shape is a bit more like not that steep. Okay, because it takes 250 microseconds to rise to the peak, and even the peak depends on the voltage system. Okay, so this will be like a slower waveform. What about the energy content? So the energy content of this, the switching voltage, test voltage, may be much higher in comparison to lightning test voltage, but it occurs. That higher energy content occurs at a longer period. Okay, so make sure you really understand the difference between lightning and switching. And I also added in the WhatsApp the link for the ChatGPT answer on the same issue. Okay. Say over here in the next yellow box, it says a switching impulse test voltage takes a longer time to rise and much longer time to fall to half of its peak value, while the amplitude depends on the transmission and distribution line system voltage, which is what I just explained just now. So there are two different sets. Why? You can see ChatGPT's answer. Now we concentrate on the requirements. The first part, 8.2, right, is on the lightning impulses that we want to inject to the samples, to the UUT. Okay, there are requirements for them. One of them is, if for lightning, is 1.2 microsecond and 50 microsecond here for lightning impulses. Okay, and then furthermore, you can overshoot, but just for like 10% maximum overshoot, meaning like if the peak you want is 200 kV, but when you measure the voltage that you inject is like 220 kV, then that's the limit. If your generation set tries to measure 200 kV, tries to generate 200 kV impulse, but then what happens is the impulse generated is 220 kV peak, then it cannot be used for the test. So those are the requirements. Further, those requirements in terms of timing and peak voltage here, peak value, run time, time to half. So V peak, TF, T rise, TF, T fall, okay. Those values have a tolerance of 3%, 30%, 20%. This is for the source, right? Remember, this is not for the voltage for the unit under test. This is the requirement for the source, okay? And these values are the tolerances of the impulse test voltages permitted from the measured value. And not this is the percentage here is not the equipment measuring uncertainties. These are tolerances. So understand the word tolerance. All right, you are required to conduct the test with a impulse generator that can produce impulse voltages with these tolerances. Okay, all right. Referring to relevant apparatus standards may be advised. For example, transformers may be injected by impulse, lightning impulse voltage because it's outdoor, switching impulse voltage because it's already in the electrical system, and faults can be everywhere. So therefore, you need to test them. Okay, you test them with lightning impulse voltage, switching impulse voltage, and it has to have a standard that really explains lightning impulse voltage on a transformer. There has to be a standard on that test. All right, with using that standard, together with this standard, you conduct the test, then the requirements are met for all, then the test should be fine. Okay, next, to generate the test voltage, well, this is your high voltage technology subject last time, so you can revisit it again. Again, 8.3, the measuring systems to be used. All right, you can use it, approved measuring system to be used in this testing of apparatus with impulse voltage, and spark gaps can be used if you want to measure. Okay, remember I have told you in class, spark gaps can be used as voltmeters. Okay, so this is what it's saying. All right, other parameters that is measured to measure include timing parameters to distinguish between lightning and switching impulses. So that clearly, if you are saying that you're injecting lightning, you must show that the impulse you produce or the impulse you produce to test on the UUT is of those parameters listed here just now. Okay. Okay. Now, worry about that. After 8.3, which is on the measuring system, we go to 8.4. Now, the test procedure, this is for lightning impulse or switching impulse, okay? The test procedure applicable to particular types of objects should be specified by the relevant apparatus standard with regard to at least the following factors. Meaning, if you want to conduct the test, you must be sure of these items from A to F. The required test voltage. If the required polarity to be used. See, impulse is like DC. You have positive impulse and you also have negative impulses. Okay. How many times do you inject the sample, the number of applications? The interval between applications. How long do you take before you inject another impulse? You see, the UT need to rest before you stress it again. Other apparatus specific procedures. This is what it is meant when you use another product standard, which shows that you want to do impulse test, and there is a standard on that. We can check on that in your assignment, because in your assignment, you will be all referring to product standards. Okay, so different type of tests and evaluation results are to be referred to relevant apparatus standards, taking into account whether the insulation is restorable. Okay, restorable. Yes, if the insulation is restorable, then there is a guide for that. Okay, all right. Let's pause a bit. Yeah, and now look at the last yellow box. Impulse shapes need to be measured, not just calculated, as noted here. Note, meaning if you want to prove you are producing those type of impulses, it is not from calculating your resistors or capacitors in the impulse system, impulse generation system, and saying, yes, that's the waveform. No, you do the calculation first, you set up the test, then you measure the waveform shape, then you can only say, yes, this is the waveform that we produce, not just by calculating like what you did in class. Okay, with that done, this is just the test procedures in general. Like in AC and DC withstand test and so on, you have another withstand test and then assured disruptive discharge voltage test, disruptive discharge voltage test in 6.4.1, 6.4.2, 6.4.3. Also in DC, you have 7.4.1, 7.4.2, 7.4.3. But here in lightning impulse test, you have the first one in attention is the withstand. Really? Withstand test? No, it is not similar to DC and AC, but we have like 3 types of tests. The first one is 50% disruptive discharge voltage test. See, oh, this is very tricky, this one. The next one, 8.4.2, rated withstand voltage test. So it's like part 1 of the DC and AC, withstand voltage. Then in the withstand voltage test, you have 3 types of procedures that you can choose, all right? And then, sorry, 4 types of procedures that you can choose, right? A, B, C, D. Then there is the second type of test. The third type of test with impulse is, again, assured disruptive discharge voltage test. Remember this? This is the voltage that for sure the insulation will break down. Assured disruptive discharge voltage test. Then it starts explaining about the measurement system again. Okay. So now you can see it is totally different actually from the AC and DC test. Even though they have 3 numbers of tests, but the first test is the 50% disruptive discharge voltage test. Second part is the rated withstand voltage test. All right. While the third part is the assured discharge voltage test. But the tricky part is that when you want to do the rated withstand voltage test, you will find out later that there are 4 types of procedure for you to choose. All right. And before that, 4 types A, B, C, and D. And finally, again, is the assured disruptive discharge voltage test. Okay. And after that, again, the measurement system. Okay, so there are 3 types. 50% disruptive discharge voltage test, rated withstand voltage test, assured disruptive discharge voltage test. See, it doesn't only discharge, it is disruptive. Okay, so now this part you have 4 procedures to choose from. So let's go with the first one. Even this one, this method is to statistically and economically determine the probabilistic breakdown voltage, because you are saying V50 is the 50% disruptive discharge voltage. Okay, so to do that, it is something about statistics. After you've got lots of data, then you're saying, oh, at that voltage, particular voltage is the 50% disruptive voltage. How? Okay, so because you inject so many times at so many levels of voltage, and then you find out, okay, at what voltages it starts to break down, and then among that range, we try to find the determine the V50, they call it. All right. If you want to find out, okay, the first method, the multiple level method, with N being greater than or equal to 4 voltage levels and M being greater than or equal to 10 impulse levels. What's this? Well, you can see, when you see you have only 4 voltage levels, right? Hang on. The multiple level method with N being greater than 4 or equal to 4 voltage levels and being greater and M being greater or equal to 10 impulses per level. And you look at A here. A, only 4 voltage levels, okay, because greater than or equal to 4. So you can have minimum 4. But with each voltage level, at least 10 impulses of each polarity. So 10 positive, 10 negative is required. While B, if you use B, because it's and being the voltage levels, and being how many impulse being injected. Okay, now look at B, the up and down method. M equals to 1 impulse per group, and N greater than or equal to 20 useful injections or applications. So therefore, for B, having at least 20 levels of voltage impulses, 1 shot per polarity. So now, which one is better? More voltage levels being recorded until it breaks down, or just taking 4 voltage levels but repeating it 10 times? Well, it depends. Okay, it depends. So here, the term M refers to the number of impulses per voltage level, and refers to the number of voltage levels. This is like straightforward, right? Okay, if you want to know the details of the statistical treatment, it is still in the standard, but I don't go to it today, okay? Because we want to go to other procedures as well, which is the withstand voltage and the assured disruptive discharge voltage test, right? So now, next one. So before we go to the next one, remember, the first one is the 50% disruptive discharge voltage test. It is a bit statistical, while the second one is rated withstand voltage tests. And as you can see here, if the impulse in testing the impulse voltage withstand, there are 4 methods from A to D. Okay, and over here it says the type of insulation should be considered, either to choose which one from A, B, C, D, and whether to apply 1 impulse voltage level. This is procedure A to C, or you apply impulse voltage at multiple levels. That is procedure D. Okay. Now, procedure A is the most economical. Okay, let me read to you the yellow box. But no failure of insulation is allowed. Okay, why? 3 impulses of the specified shape and polarity at the rated withstand voltage levels are applied to the test object. The requirements of the test are satisfied if no indication of failure is obtained using the methods of detection specified by the relevant standard apparatus standards. Meaning that here, no failure is obtained whether you look at it visually or whether you look at the oscilloscope. There's no voltage drop or voltage breakdown. When there's a voltage drop, then it passes the test. So in this test, it is very economical because, well, your UUT is still okay. It is not yet damaged, okay? But that's it. While procedure B, you inject 15 impulses of the specified shape and polarity. Just now, how many? 3 impulses. Here, 15 impulses at the specified shape and polarity at the rated withstand voltage level are applied to the test object. The requirements of the test are satisfied if no more than 2 disruptive discharges occur in the self-restoring part of the insulation, and if no indication of the failure in the non-self-restoring insulation is obtained by the detection methods. Basically, there's no breakdown. Okay, so it passes the test if it breaks down no more than twice. Right? If it breaks down once and then you keep testing again, or out of the 15 impulses, only break down once, then it passes. Out of the 15 impulses, it breaks down twice, then still it passes. All right? Like, that is procedure B. Okay? B requires more impulse shots because this is just 3 shots, positive, negative. Here, 15 shots, positive and negative. That means 30 shots. But 2 disruptive discharges is allowed to pass if confirmed occurring on the self-restoration part of the insulation. All right? If it's the air has discharges, then when you don't apply the impulse, then it is restorable. Insulation is good again. Okay? And while C, look at my yellow box, C only requires 3 shots per polarity. But if 1 disruptive discharge occurs, another 9 disruptive discharge is required to pass the UG. Okay, so if you read further, out of the 3 impulses, any failure, then you have to inject another 9. And see, are the failures occurring again? Okay, and if no disruptive discharge occurs, the test object has passed the test. Okay, so can you see between A, B, and C, which is economical? Okay, depends on what you want to test. Right now, we are not sure whether we want to test insulators, string insulators, or whatever, transformers or switch gears. We are not sure. Okay, but when you know what you want to test, then you can choose between this procedure A, B, and C, and of course, D. Procedure D is for self-restoring insulation in evaluating the probabilistic breakdown voltage. So which means the up and down method can also be applied here. Remember last time we stand voltage, up and down method, you rise up the voltage. Okay. All right. For self-restoring insulation, the 10% impulse disruptive discharge voltage V10 may be evaluated by using statistical test analysis procedures described in 15. Okay, so here on procedure D, you have to refer to 15. You take a set of data, all right, and then if you do 8.4.1, you get your V50, right? Here, you want to evaluate your V10, all right? So they have an equation, okay? You can evaluate your V10 using this formula, all right? And then you do the test, you get the data, and if you look here, I have summarized with you, at least 56 impulse shot is to be applied as explained in this last paragraph. Okay, 56. So 56 impulses here. You got the V10. Okay, here 3 shots per polarity for procedure C. If it fails, then another 9 shots. If it doesn't fail, it passes. Here, procedure B, 15 impulses per polarity. Okay, 2 failures is still a pass. A, you inject the voltage that has been set by the customer or by the manufacturer of the UT and make sure it doesn't fail. That's it. Okay, between A, B, C, and D. Well, 8.4.2, all right, is the impulse withstand test. 8.4.3 is the assured disruptive discharge voltage test, which is for sure it will disruptively discharge at this voltage. All right. So this is like AC and DC assured disruptive discharge voltage. As with assured disruptive discharge for HV and AC and HVDC, the discharge must occur before the assured disruptive discharge voltage, referring to the relevant apparatus standard. Okay, as for HVAC and HVAC as well. Okay, so the procedure for an assured disruptive discharge voltage test is similar to the one described in 8.4.2. So you think it's economical? No, it is similar, except that the test object should exhibit a disruptive discharge rather than a withstand. Okay, so 8.4.2 is you have that 4 procedures, A, B, C, D. There. If you want to do assured disruptive discharge voltage test, you have to choose between A, B, C, D as well. Okay, right. So, but then what is the difference? The test object should exhibit a disruptive discharge voltage rather than not discharge. Okay, so after this, it starts explaining about the measuring system again. Okay, which means we have done all the, we've gone through 8.4.3, which is the assured disruptive voltage test, and this has 4 procedures. And the 4 procedures is also applicable to 8.4.2, which is the withstand test. All right, this is procedure D, using statistics. This is procedure C, 12 shots maximum per polarity. This is procedure B, 15 shots maximum per polarity, but passing criteria is a bit different. And lastly, procedure A, okay, which is no discharges should occur, then it passes. So it is most economical here in terms of the UUT. But in terms of conducting the test, then it depends on the customer actually. The customer wants which test. And not to forget 8.4.1, which is the 50% disruptive discharge voltage test. Maybe we could concentrate a little bit on this type of test as in terms of looking at the results and so on. Okay, and then section 9, we've done section 8. Section 9 is on impulse current, not covered in our syllabus, but you can read through, it's still in the standards. And section 15, where we have these up and down methods and so on, statistical methods, should be given attention as it details out how to treat the test results statistically. Okay, you can check for internet, and I will share a few in class. Thank you. We stop here, and maybe another video will come. Maybe we continue where we continue off from this video. Thank you very much. I hope it is fruitful, and see you in another video. Assalamualaikum warahmatullahi wabarakatuh, and a very good day.